Good afternoon. I'm delighted to talk to you all about a new effort by my colleagues and I to use hyperspectral imagery to assess kelp forests here in New England. Now, I want you to stop and pay attention to this title slide and notice what a kelp bed looks like to those of us who are working in New England. Remote sensing has made tremendous advances in looking at kelp forests throughout the world using Landsat. However, a lot of this work comes from kelps that form surface canopies. In other words, they come up and actually trail fronds along the surface of the ocean. This work has been a huge advance in our understanding of kelp forests at scale. However, in most of the world, kelp forests look a lot more like that previous slide. So I ask you to take a look at it. So most of the kelp forests around the world, these beds of big, beautiful, bold brown algae, that form the habitat and base of the food chain for these systems, sit underneath the surface of the seawater, making it much more difficult to sense them using satellite methods. Now, there are some solutions on the horizon, and that's what we'd like to tackle. Recently, some groups have been using hyperspectral imagery on drones and UAVs to begin to map kelp forests. So for example, in this work from Uhl et al. In 2016, they were able to match up the spectral signature of Laminaria digitata in the lab to Laminaria digitata. This is 2 meters, but actually down to 5, and in some cases, even 10 meters in depth, and then map the forest around Helgoland. This was a really huge advance, and they actually did this work in anticipation that researchers like us in the future may be doing this with satellites. We've begun looking at some different satellite products and looking at the spectral signature of the seafloor, at least at relatively shallow depths, and found that we are able to get some good signatures that are different, we're able to use to differentiate different habitat types, sand and submerged aquatic vegetation. And so our first goal really is to develop a way to use Prisma and DESIS hyperspectral approaches to classify kelp between 2 and 5 meters in New England. Now, these satellites have launched much more recently, and so our second objective is to cross-calibrate these using deep learning against Landsat and Sentinel-2, as well as other imagery sources, in order to generate a longer time series of kelps throughout New England. If we can't get kelps per se, heck, a time series of submerged aquatic vegetation over time is going to be incredibly useful to understand this rapidly changing place on Earth. Our goal is to then use this data and model it with sea surface temperature as well as other data layers using causal econometric techniques to try and pull out the different drivers of kelp abundance within New England. We may use products such as the NOAA OISST, although really we would like to use more satellite products, particularly those with better resolution. So I think there's some really interesting work to be done here. I've been doing this work with colleagues using diver sample data. I am a community ecologist, a subtitle community ecologist, and we've had tremendous success so far. However, there are some real questions about scaling it up regionally. Finally, as part of our institution, we have some real solid educational goals. Our team is a really interesting one. We're a team of subtitle community ecologists like me, a variety of people working in remote sensing in different areas, as well as people working in side scan sonar. In the past, we worked on remotely sensed kelp forest products, such as the citizen science platform, Floating Forests, using Landsat data, and found that weaving kelp forest and climate data into our curriculum can have very strong impacts on learning objectives within the classroom. So this is actually a work that one of my graduate students is about to publish. So we're going to continue that work, but with data that's closer to home. We're also interested in working with the UMass Boston Institute for Native American Studies to develop a workshop in remote sensing in GIS to go into and work with Native communities for the different needs that they have and give them some of the tools that we have, as well as forge, I think, some really strong partnerships for the future. So with that, thank you very much. I look forward to talking to you more. Also, our project is currently hiring a postdoc. So if you know anyone who would be interested in this, please have them contact me. I'm really delighted for this work to get off the ground and to see where it's going to go. Thank you.